Next seminar will be chairperson is Dr. Jeffrey Dominer from the St. Luke's Medical Center, Quezon City, from Philippines, and Mr. Shintaro Ueda, and from Tembec Kyushu University Hospital. Okay, time is yours.
Hello, I'm Shintaro Ueda from Kyushu University Hospital. I will chair this luncheon session with Dr. Jeffrey Domino. And the luncheon seminar is supported by MediPlus Incorporated. And their title is Challenges and Future of Surgical Video Management. And we will have Natalia Yardanova and Roger Hicks give a presentation and a demonstration. So let's wait until they get prepared.
Yeah, good afternoon, everyone. So while they're still preparing, you can have your lunch while we will be watching you. So go ahead. Feel free to enjoy the lunch. I understand. That's okay.
PC は2つになりますので、PC は2台ここに置くことになりますので、多分どうする方がいいですか？はい。まあ、もしかして難しいなら、ちょっと PC はここに置いて切り替えする。マスクなしでよろしいでしょうか。西田さん、ロジャー読んでもらえますか？ロジャー読んでもらえますか？ I'm waiting for Roger to come inside. Roger no PC mo. Both of us, I'm presenting first. Yes, he will be doing the live demonstration. ないです。No, no music. Oh,
Please get prepared.
careful for the cables. Alright. So this is kind of like this space setup we have. You have enough space?
I think so.
Okay, your HDMI is on this side.
Actually,
It was on the other side.
now it's on
Yeah, so this is gonna be the cable. I guess make sure you're. You know what, I can pull away my connection.
Actually, we can move our computers around.
Because the mic is right here.
Okay.
I'll just pull mine off and you can connect yours and center it when we're changing to yours.
I'm gonna come over here.
Okay. 何そうそうそうそう。なので、ロージャーは多分、ロージャーの PC の番になったら PC ここに。ここかそうそうそう。うん、先に音声の。
Can we start?
はい。
Okay, so let's start the Luncheon seminar. So let's have Natalia and Roger from MIDI Plus. Okay, the floor is yours.
Hi, I hope everyone's enjoying the symposium right now. My name is Natalia Yordanova. I work as a client support specialist at MediPlus, and this is my colleague Roger Hicks. And he works as a programmer who is actually in charge of developing some of the demo stuff that we have to present for you later on in this presentation. So for our presentation, we will be discussing a short introduction on MediPlus's existing system, as well as how current private information regulations, laws, and restrictions have been impacting the medical industry, and what MediPlus is doing to develop ways to assist hospitals to better regulate this information so that doctors can safely and easily use this video data. So, MediPlus Incorporated develops, manufactures, and markets the SRS surgery recording system. The company is the first in the medical industry to offer an evolutionary type of recording system with no maintenance deadlines, and we regularly offer version upgrades for hospitals, and the number of hospitals in Japan that are currently utilizing our surgery recording system is always expanding. Now, our mission statement is that we develop evolving management tools for professionals, for healthcare professionals, and contribute to not only increasing productivity, but also profitability of hospitals. We do our best to fulfill this mission statement in a variety of hospitals across Japan, including here at Kyushu University Hospital. So, to give you a better idea of what our system does exactly here at Kyushu University, as well as other hospitals, we have a short presentation. So, As many of you are already familiar, this is the inside of the operating theater. And in this video, you can see that they are currently doing an endoscopy. So you can see in the back that there is an endoscope machine with a monitor. However, from that endoscope, we take the video signal and put it into the surgery recording system. From there, we can either redistribute that video back into sub-monitors such as wall monitors, ceiling monitors, and so on, or the same video is also being recorded in the surgery recording system. Now, the reason why this is useful is because not only the surgeon has a good view of what's happening in the surgical site, but also the anesthesiologist or medical students who are in the operating room also have a good visual on what's happening in the moment. This is very useful in case there is an emergency or quick reaction is needed. Everyone in the operating theater is already aware of what's happening on the surgical area. So if you look in the back, there was actually MediPlus's SRS, and it's a very simplified interface. You just have to input the patient ID and press record. You can also take real-time screen captures of what is happening in case you want to revisit that later on. However, the true star of what doctors find most useful actually is not just the SRS itself, but the media center that we offer. Now, the SRS Media Center is actually the first of its kind in the industry where you can access the medical surgical footage from the electronic medical records. So as you can see here, the doctors have pulled it up on the electronic medical record, which is on the hospital's network. And they are using it to play back footage for a conference or for their own, or you can use it to reflect on your own recent surgery as well. This is really good for conferences, for not only for interdepartment, but you can access this anywhere in the hospital from any of the medical record terminals. And not only can you access recorded footage, you can also look at the current live surgery as well. This allows doctors who are maybe senior doctors or medical students as well to monitor things remotely. If they are in their office or in another room in the hospital, this is a great way for doctors to quickly consult from a remote place if they are not in the surgical area at the moment to offer advice or help out the current surgeon. So MediPlus can actually record up to currently 4 video streams at the same time. So if you have the endoscope video, but also you want to take in the video from the vitals or from the surgical camera from the ceiling, or if you have a separate remote hand camera, you can do this. And when you have it played back in the media center, it looks like this. So you can see all 4 video streams simultaneously. Currently, there's an angiogram as well as 2 endoscopy videos. And the 4th video is actually using our company's composer. The composer is done in real time. So this is post-recorded footage. And you can play this back. You can change if you want the main video to be big and then the 3 on the side, or you can have them in a 4-screen split. And you can very easily navigate through the video. You can take a screen capture this way as well. Before we mentioned during surgery, you can do active screen captures. But if there's something you would like to afterwards, you can always take a screen capture then and add memos. And the benefits of these screen captures is that afterwards you can use them to very quickly jump through key points in the surgical video, which makes it easier during conferences without having to download or necessarily edit the video down. You can just pull it up on the electronic medical record and you can jump to the necessary point you need for your conference or presentation. So now that you have a better idea of visually what our system looks like, I would like to explain the general layout of how our system works. This is a very simplified diagram. So the SRS is a 5th generation surgery recording system. And I'll start off by explaining the diagram that's here in the center. So As you can see on the far left is the surgical theater. This is where your surgical video inputs will be, whether that's vital information from the vitals machine or from a surgical camera, endoscope, so on. And really anything that has a video output signal, we could find a way to connect it. And that can be sent to the SRS for recording. And we also have a kind of a medical safety video backup as well, which is used in case there is a problem later on. You can quickly see what the vitals were like. It takes everything side by side. That can also be viewed depending on the hospital's request. And all of this data gets sent to the server. The server acts as a kind of core access point for both receiving and forwarding information. This is usually MediPlus's server that we put into the hospital. And what do I mean by forwarding that information? I mean, as previously stated, the digital medical record terminals. So the electronic medical records, we can make it so that any medical record in the terminal in the hospital can access the server. That's basically what the media center is. It's an access point for all that server data. So by forwarding all this data from the server, and also it allows doctors to edit and save their own footage. You can constantly, from any medical record, you can view live surgeries, view your own surgical statistics, you know, how much time your average surgeries are, what's your longest surgery, and so on. And as you can see, MediPlus really focuses on the utility, not just the recording in the moment of the surgery, but also the utility after the fact for those videos for hospitals. Rather than, in addition, by regularly upgrading the system, MediPlus is continuously evolving. I'll explain in a moment, but evolving meaning ours is a software-based system, not hardware. So it allows us to constantly do upgrades for both not only the recording system, but the media center as well. So the key features of the SRS are three main features that we like to really emphasize to doctors. Feature one, as you saw in the video, there are recorded videos as well as live videos that can be viewed through the media center at any of the medical record terminals, or depending on the hospital, we also have our designated terminals that we add in addition to the existing medical record terminals that are specifically for either viewing or even exporting the necessary footage to your own personal USB or SSD. And this usability of the accessibility through the medical record terminals, we've been told greatly improves the physician's work efficiency and contributes to an overall improvement in the quality of service and care that they can offer to patients. With the SRSs on the media center side, using both a powerful search engine and a my page function, the SRS allows you to very speedily, readily access the necessary footage. The benefits of this are that, for example, surgery has just completed, the surgical footage has been sent to the server, and you have a consultation, post-surgery consultation with either the family or the patient. You can very easily show this footage playback as soon as it is available on the server. You can play this back and show key points during the surgery if there's anything that needs explanation to the families or the patient themselves. It also allows, as stated previously, to follow along in real time. That's not only beneficial for senior doctors who might be monitoring the situation, but also for medical students. During COVID-19, I'm sure there was a lot of restrictions on how many students could be in these classrooms or in the actual surgical site due to, transmission restrictions. So also, in the event that any gauze or other items might have been lost during surgery that cannot, you can also very quickly play back the surgical video to look and see, oh, where might it have been lost, and to see if there's a need to go back in and open up the patient. Overall, there's many ways to utilize the features of the media center, and it's all really done to help physicians have the most efficient and high quality services with patients. The second feature would be the indefinite support. So due to the nature of most surgery recording systems, since they are hardware-based, there is a limitation to how long the warranty period is for them. However, with MediPlus, since we are a software-based system, our support through the SRS support program is indefinite. There's constantly updates, and we will always make sure that you, through the request of the hospital, if you upgrades in technology. For example, if you're upgrading from HD video footage to 4K video, we can accommodate through software methods to support that. And all of this can be done at a relatively low cost because since it is over time, there's no need to do a whole hardware overhaul as it would with most surgical systems. And that is something that can be a financial burden on hospitals to every 7 years or so have to invest in an entirely new surgical system. Feature 3, which is an extension of feature 2, is the continuous upgrades. So over the years, MediPlus has updated their both the encoder, which is the recording feature, as well as the media center. Before, the media center would only be able to play back one video stream at a time, but the current media center actually plays back all 4 at the request of doctors who wanted to be able to see side by side in real time what the vitals were like, or seeing the surgical camera alongside the endoscope camera to see how the movement of the doctor's hands are and what techniques they use. And many of these upgrades, both to the SRS and the media center, are actually from our client hospitals. Being able to talk with the hospitals and consult with our company, we're constantly adding new features to make it more useful and easier for doctors to access our system. And these upgrades are constantly happening, and it's very easily to consult with us, and it's not necessarily an additional fee. There's no additional fee for us to incorporate this into the next update from the hospital side. And so many of our ideas are actually from doctors who say, we would like to have this in our system, or we think this feature is good, but the interface is a little bit complicated. Can you please simplify? And these are things that we can, with updates, adjust. But what exactly makes these continuous updates possible and the support continuous? And that's actually the secret of SRS, which is being software. Software encoding compared to other systems which use hardware to encode. Now, the difference being is that, as you can see on the left, other systems use hardware methods to encode, which is done through a chip inside the device. The chip is specialized to be able to compress and convert video footage. However, the advantage of this is that it is compact. This allows other companies to make very specialized electronics to record this video. However, the downside is since it's hardware based, there's not really many options to upgrade without having to buy a completely new recording device. So if you originally purchased a product in HD, it does not support the 4K quality of a lot of endoscopes that are being purchased by hospitals recently. However, with SRS, it is a software encoding method. Use it to compress and convert videos through the power of programming. The advantage of this is that it can constantly be updated to accommodate new video formats, new video quality, resolution quality. So. Now that we've covered the SRS, let's talk a little bit about how not only COVID-19, but in general, there has been a push for regulations in data privacy, personal information privacy. Like in every industry, the healthcare industry is also evolving, and with a great push from COVID-19, it has forced the industry to make rapid changes. And since the environment surrounding healthcare healthcare professionals is constantly changing, so does SRS, and so do hospitals. In recent years, due to the push in restrictions for information privacy, in November of 2022, the Personal Information Protection Commission declared that surgical images are personal information and that the disclosure of personal information without the consent of the patient is prohibited and is illegal. And therefore, if this footage were to be used in maybe a conference setting without the express permission of the patient, or if by chance a hard copy that the doctor happened to take out on a USB or a DVD were to get lost, disappear, that makes not only the doctor, but the hospital liable as well. So until recently, the individual doctors or medical departments were in charge of regulating this video download storage. But with the increase in privacy laws, it is expected that doctors themselves will no longer allowed to manage, and will rather this burden will become this burden will be placed on the hospital administration itself. Now, how do we would like to ease this burden on the hospital administration. So we've come up with a few ideas for developments we would like to incorporate into the SRS. So using outdated systems are a major management risk. And so we would like to introduce things like the SRS Cloud or the SRS Protection. The SRS Cloud would allow doctors with the access rights to be able to look at their video footage without having to download it in a secure space. And then the SRS Protection would allow for doctors, would allow for a masking to be incorporated on top of the video. So that way, if other people, whether that's other doctors who are not in the department, or if you're using it for a medical conference, which is to use it, the face becomes anonymized, and therefore it is protects the patient's privacy. But to explain these new features will be my coworker a little bit later in this presentation. But overall, SRS will strive to provide the support that healthcare professionals require in this rapidly changing environment. So, medical movie big data. The platform is a next generation service. So big data refers to the accumulation of large varying data. So not only has high volume, but also a lot of variety in the data that it can offer. And when it comes to big data, it becomes outside of human capabilities to manage that kind of data. And that's where AI management comes into play. So, by using the masking feature that we mentioned earlier, by anonymously processing it, it can then be used on the big data platform for not only surgeons from other departments or possibly other hospitals in the future to access this data, but also allows companies like MediPlus to utilize the anonymized data to help further AI and other developments for hospitals, so we can make better quality programs for clients. With the power of processors and dramatic advancements in AI, all of these new services could be completely possible. It's just a matter of being able to utilize the data. So the reason why masking is so important is because while the new laws and acts in Japan say that surgical video is personal information, the laws and acts also specify that anonymized surgical footage can be utilized and given out to third parties without the express consent of the patient. So if the data is anonymized, it does allow for our company to go through and use this for our own software development so we could provide better trained AI and other technology for you. But to better explain this anonymization process, as well as other future developments we might be having, my coworker Roger Hicks will now explain how we are creating what we can create using this data.
Hello, I'm Roger Hicks, and I'm a software engineer at MediPlus. And one of the things I'm helping to do at MediPlus is support the medical movie big data platform, which is the future vision of MediPlus, or one of the future visions, of course. So, as my colleague Natalia spoke about earlier, we are advancing the medical support services through software, and obviously through AI as well, because AI is created through software. And, you know, the main reason I think we record data, especially surgical video, is to learn from it, gain insights that help us improve surgeries for other patients in the future, and, you know, accelerate our ability to learn it as well, and support surgeons through services such as annotating when you're doing a teaching session, and maybe intelligent searches of the data that you've collected as well through AI. Those are some of the things that we are starting to focus on right now at MediPlus, amongst the other things that Natalia spoke about. So one of the key things that she just spoke about was anonymizing data, and basically, you know, we want to learn from data, but we don't want people's personal data. And that makes it very difficult for us to share and teach information to people, because we have to be very careful about what information we share with them, even if it may be helpful. So how can we get around that? And that's through anonymization. If we anonymize patients' data or anybody's data, then the information becomes generalized and you can learn from it without any personal harm to anybody. Oops. So we have an example video here of a perfect masking video that we did. So we can share this video. Basically, as you can see, all text is completely masked out. I'm going to play it one more time just so you can see. All text is masked out, although we have settings where you can or we have interest in the future to unmask certain data if you want that to be unmasked. But as you can see, no matter how you rotate the camera, if you zoom in fast, slow, if it's at a weird angle, it doesn't matter. It's perfectly masked no matter what. And I want to try to test it even tougher and do a live mask if you guys are up for it right now. Let's see. So as I mentioned before, this software basically gives you the ability to mask out many different types of data. You can mask out a full body. You could detect people's bodies. You could detect their face. You can even detect their hair and other objects as well. And you can also detect text, and you can read the text and utilize that. But obviously, that is not what we're doing. We're anonymizing the data. So, um, waiting here for this to load up. Okay, so it looks like I'm not sure how many people are in here, but it looks like everybody's data is secured. We're safe. Uh-oh, who's not safe? Front row? I don't see it. Oh no, I see. You're right through the computer. Okay, that's a blind spot we got to figure out. But um generally, you know, especially if you don't have a mask on, you are completely masked and nobody can see who you are. Um so and this is all happening in real time. So I can move the camera around, as you can see. Um, so that's one demonstration that I wanted to show you guys. And this actually was the lowest accuracy setting. This is actually designed for real time, but we have uh, a version designed for high quality and high accuracy that is basically meant to be perfect no matter what. So no matter how long or how many people it will catch it. Let's move on to the next slide. Moving on to another technology we're working on. So I'm sure you guys are familiar with 360 cameras. Um, and as you can see from this image here, this is the format. Oh, sorry. This is the format that um, 360 video is recorded in. It's kind of warped on the outsides. So you need a special player to actually utilize this type of video. But I think again, you know, I heard you guys talking about teaching other students and sharing information, and I think immersion is a huge part of that, and seeing what's a part of the operating rooms, what's happening during the procedures is important, and this type of video can help. So we do have a 360 viewer as well, which I'm going to show very quickly. So this is the 360 viewer. And one of the capabilities, this video is kind of low quality right now, but even in 4K, you can zoom in basically forever if you wanted to. And this not only runs, this runs in the browser, this runs on any device on your phone. And you can use your gyroscope, you can use your heads, a VR headset as well. I have just one more thing I'd like to show. So looking toward the future, again, thinking about how we can help doctors. And in the future, SRS will enable doctors to communicate problems accurately during surgery by annotating on the surgical video in 3D. Compared to other annotation programs, our annotation program tries its best to retain the positions and the 3D structure. And I think this is important because, again, immersion is important. And when you're teaching people how to do things such as surgery, and they can't actually be in the room, but if they could actually see it and actually see it as if they were in the room, if they were the surgeon, and the surgeon or the teacher was guiding their hand, or at least giving them some type of instruction. This will be my last demonstration. So what I'm showing you here is a work in progress. You're welcome to judge though, because we're looking for feedback, of course. But basically, what we have here is a video of a surgery done with the Da Vinci robot, if I'm not mistaken. And in real time, we have a 3D reconstruction that's being built. And I can draw a line here. And you see that line actually goes over to the 3D reconstruction where the gauze is here as well. So now, as you can see, like I said, this is a prototype. But this goes a long way because basically you could on the there's two different techniques that are being used here. On the left, there is the camera position tracking. It's kind of being reverse engineered from one camera. There's no gyroscope or anything. There's just an AI that's looking at it frame by frame and comparing the pixel data. And then on the right, you have something called a depth map, or a depth estimation, basically. And in real time, while this video is going on, it's actually reconstructing a 3D model of the entire video. So this is one demonstration, but I wanted to show you one last one, which shows you a little bit more depth. So this one it's the same video, but here, as you can see, I'm pressing a button on the computer right now to basically tell it when to try to detect depth, because doing it real time requires a lot of power. But if you have two really nice computers, or when we optimize this really well, we'll be able to have high res 3D reconstruction in real time, as I showed you before, and you'll be annotating directly on that. Even as the tissue may move or whatever, you will still be able to see your lines clearly as if you were there during a surgery. So thank you.
So we would like to thank you for listening to our presentation. We're sorry it got a little bit rushed. But if you have any questions for us or anything you've seen in this presentation, feel free to ask.
Okay, thank you for your presentation and impactful demonstration. I'd like to have questions from the floor, or maybe before that, Dr. Domino, since you're a surgeon, do you have any comments?
So thank you very much for the presentation. Just some clarifications. Will the compatibility of equipments, you see in surgery, we do have several equipments,
Yes.
especially in robotics or laparoscopic surgeries. Will this be an issue in terms of recording?
So generally our system, we will take a variety of inputs through existing industry converters. It kind of depends on the setup of the hospital, but more often than not, we tend to attach the converter to the device, and then our current method of wiring is converting everything to SDI, and then that goes into our system.
So there's no problem with compatibility.
As far at this moment, no.
Yeah. So that's good. So which means when we record it, you mentioned about the SRS cloud.
Yes.
Is that web-based or only in the hospital, or it's an intranet cloud
So
only?
at the moment, we're thinking intranet, so inside the hospital on the server environment. But in later to be able to, as in the diagram, for doctors to still be able to access that server remotely through hospital approved user login.
So later on, it can be developed.
Yes.
Yeah, and you also showed us how you can manipulate the anonymizing.
Yes.
Yeah.
Yes.
So if you can do that, you can also manipulate the face, meaning you can put my face to Satya's face. That way, is it possible using the AI technology that you're using?
That is not our focus at MediPlus.
I'm just saying that it is possible.
But
I'll be
yes,
happy to
that is-
have my face with Satya's face.
that is
no?
100% possible, and sometimes you got to have fun and laugh too.
I know, yes.
So if you guys want to swap faces, I don't blame you.
Thank you
But
very
yeah.
much. Any question from the floor? Yeah, Satya, see, I told you.
Yeah, I'm Satya from India. In your presentation, you mentioned that at a time we can record 4 videos.
Yes.
So 4 individual recordings, or it is like one screen will have all the 4 videos?
It's 4 individual recorded files. In the video presentation that we showed, the 4th file was actually in real time using our SRS composer, which in real time you can compose 4 different inputs into a single image, and that got recorded into the 4th place image. But in the media center, all of those 4 images are separate video files. So when you're downloading them, they download as separate individual MP4 files.
Okay, thank you.
Yes. Yes.
First of all, thank you very much for the very appetizing images during the lunchtime.
I apologies.
Thank you for that. My brief question is, what's the level of uptake at the moment in Japan and overseas of this software?
So currently our system is utilized in Japan at the moment, but we do plan to expand possibly in 2025 overseas. But currently it is in Japan. I think I want to say over 200 hospitals, but I might be wrong on that number. I apologize. But yes, we currently service all across Japan. I do not think we have a hospital yet in Hokkaido, but I do know that we are expanding toward Okinawa currently. I specifically support anywhere from Miyagi Prefecture all the way to here in Kyushu. So our office generally supports all across Japan. Not overseas yet. We are looking to expand. I think the easiest technologically wise would be the media center to expand overseas. It requires, I would say, the least amount of in-person support for those types of situations. And to my understanding, that tends to be doctors' favorite, actually, portion of what MediPlus provides is the media center itself, the capability to access the server from any of the electronic medical records and terminals, and be able to have more, to do simple editing and things like that from the ease of their own computer.
Okay, Kuriko?
Yes.
Thank you very much for support this ATS, and also thank you very much for the nice presentation and support your system in the Kyushu University. And I realize that you are trying to develop the 360 image, and we are also really interested in. But I noticed that the quality of the resolution is not still very well, because the 360-degree camera have a lot of the bigger the resolution is needed. So it should be increased resolution in the future, but in that case, more the security problem will be happen. For example, the open the door in the operation room and the other patient is walking through, then you
Yes.
need to worry about the information, or if the monitor shows each the HI the electronic health records, then
Yes.
the ID or name information should maybe maximize when we zoom up, we
Yes.
may see. So yeah, this kind of things needed. So do you have any opinion about this?
I think that we will definitely have the services to help you because I think that's something that we're focused on right now is just keeping everybody's private information private, and through the anonymization software that we're building right now, as you saw, we actually removed the names on the vital machines, and we removed their faces. And I'm pretty sure, even if there was a patient walking across the room, it would still remove their face. So I think we already now have the capability to do that. So that's awesome to think about now. We're kind of in the future. But we also rely on you to tell us what you need, so I really appreciate you saying that.
Yeah.
So thank you.
Okay, thank you very much.
Maybe looking
Dr. Ho?
into masking applications in 3D would be a good way
yes.
to move forward.
Question from a non-technical person just puzzle me that the amount of data is going to be stored in this will be crazy. Talking about 1 hour endoscopy video under high definition is 10 gigabyte. You're talking about 360 few hours, maybe 100 gigabyte a day. And eventually, if you're going to record it, it will be thousands of terabytes. How do you manage that kind of large data? I don't know.
Well, I will, the best that I can answer this is that compared to my knowledge, the competitors who use hardware encoding, our file sizes are actually compressed to a much smaller size while still retaining the high quality, full high definition, or 4K if the hospital has that set up. So for example, what one of our competitor systems would take, say, 1 hour full HD is in 10 gigabytes of data. Our system usually does that in about 2.7 gigabytes. So first of all, we, through programming, reduce the file size compared to the hardware encoding method. And then we are hoping, I I apologize that I'm not quite so understood about how the hardware side of server storage will work for the cloud system. But that is something that has been discussed, and we are working toward hopefully reducing that burden on hospitals for the physical storage size for the cloud.
Okay, so thank you very much. With time restraints, I think this will conclude this session. Thank you very much for your presentation and demonstration.
Thank you so much for having us.